Okay, so in this part we're going to finish up for the last part. We got 3/4 of the way through this problem. We did f plus g, f minus g, and f times g, but we hadn't finished f divided by g. So let's do that one. F divided by g is just listing them one over the other. So f is 2 minus x and g is 3x plus 1. So this is simplified. We can't divide those two. Now it says state the domain. Now every one of these domains is all real numbers. So the domain of all of these is all real numbers. But on this one we're going to have an exception because we have a denominator now. We created a denominator in this one. So this one's going to be except where the denominator equals 0. So we'd say 3x plus 1 equals 0 or cannot equal 0. 3x plus 1 cannot equal 0. We'd solve that. 3x cannot equal -1, x cannot equal -1/3. So that's our restriction in this thing. We'd say all real numbers except -1/3. Okay, or we can write that in words. So that completes problem number 11 that we started with before on the review. So let's move on to 12. 12 does some things with functions, with graphs of functions. It asks, let's go back to the review and see, 12 asks you to be able to read function values, find intercepts, read and state domain, and identify intervals of increasing or decreasing. And it asks you to do these problems. So those are the ones I'm going to cover right now. Here's 12, these two problems, and this one is 12 down here. And then 13 is on the bottom here. So we're going to do 12 and 13 on this video, and a little piece of 11. So right now we're going to start with this problem 16. It says use a graph, find the domain and the range. Well, the domain for this function would be the x value. So we'd start at this value here and we'd end at this x value over here. So the domain on A, domain is, since the points are solid, the domain would be a bracket from -4 to +3. The range is also a bracket, but it's the y value, so we'd look at these y values here. The lowest y value here is this one, so we'd start the range at -3 and it would go up to +3. So that's the range, domain and range. Intercepts. Well, there's only one intercept. It's the x and y intercept. That's 0, 0. That's the only intercept on that one. Looking at a graph and figuring out f of 2, what we would do here is we would look at what it possibly could be at 2. So we're going to go over to 2 right here on the x-axis, read up to where the graph is. So in this case, it's approximately 1.5 up. So part C would be approximately 1.5. Oh, we're reading -2, sorry. That's incorrect because that was +2. So -2, we go over here, and that one gives us an exact value. So it's going to be exactly -1. So since the point is -2, -1, our f of -2 equals -1. D, it says find the values of x where the function equals -3. Well, I look at that as the y-axis has to be -3, so it has to be right here. So where is that function hitting this line? Well, it only hits the line once right here on that point. So part D on this one is only at -4. X equals -4. Now, if it happened at more points, then we would list all of them. Now, it says on the last part of this, E, it says solve for f of x greater than 0. So that's asking you where the function is positive. So that's going to be all the values above this line. So there are going to be several values of f of x that's above that line. So we're trying to find the x values where that occurs. Well, this piece right here is the piece that's above 0. So we just need to state the x values where that occurs. So it starts at an x value of 0 and runs all the way to the x value of 3 because that's the x values there. So in this case, it says greater than 0, so that means we're going to start at 0 and go to 3. We're going to include 3, but we're not going to include 0 because it says it doesn't include 0. It's where it's greater than 0. So this is the values where that occurs. It's going to be x is greater than 0 and less than or equal to 3. So this is letter E on this one. It's an interval because there's several answers there. All right, 17, asking similar questions. Domain or range? Well, domain is x values. So it has the arrow going this way. So that means the x values go on forever this direction. So the domain on this one starts at negative infinity. It's way down here, negative infinity. It's going to travel left, 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 left until it gets to this point right here. So it's going to end at 4. So the domain is negative infinity to 4. The range is how far up it is. So it's going down and left. So it's going to go all the way to negative infinity. It's going to start way down at negative infinity on the y-axis as well. It's going to go negative infinity on the x-axis and negative infinity on the y-axis. And the range is the y values. Okay, so we're coming up, 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 and then we go back down, and then we finish going up right here. That's the highest point. So we'd end at 3 on the range. So the domain is negative infinity to 4, and the range is negative infinity to 3. Now, intervals of increasing or decreasing. That's when we travel left to right. So in this function, we're going to go left to right, and this seems to go up, 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 from coming up from the left till it gets to here. So it's increasing from negative infinity until it gets to this point, and that point is when x is negative 2. Then it goes down and decreases, 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 then it increases again on this piece. So it's increasing twice. So we would say union with another piece. We start increasing again at positive 2 here. That's the x value. We always look at the x values for our intervals. To positive 4. So right in here, we're graphing increasing. Whoops, not 2 again, but 4. 2 to 4. Now, as I said, we are decreasing. We are decreasing in a little section right here, from x equals negative 2 to x equals positive 2. So we'd also write that as a decreasing interval would be negative 2 to positive 2. Okay, that's part B. Part C, it says locate maximum and minimum values. Well, there is no minimum because it's negative infinity, it goes forever. But there is a local maximum and local minimum here on these values. There's 3 of them actually. So in part C, there are 3 local max and mins. And that would be this one here, that's a local maximum. This is a local maximum, and this is a local minimum. Because this is the highest point around it, so this is a local maximum. Now I call them local, or it's saying local here, it's not absolute. This is a maximum also. Because around this point, this is the highest point. It comes up to that point, then drops it back down. So this is the maximum point. Negative 2, 1 is a maximum point. 4, 3 is a maximum point. Now the values for this, there's a maximum value at 1 here, and a maximum value of 3, and a minimum value of negative 1. All right, now part of these questions were in problem 13, so I'm just going to add them in here, so you'll see them later in the next section, but I'm still going to answer them right now. It says, determine whether the graph is symmetric with respect to the x-axis, y-axis, or origin. Now, this one is neither. There is no symmetry here because of this arrow. If this had stopped right here and not continued on, then it would have origin symmetry. You could rotate it and match it up. But since it stops here, there's no symmetry. If this had continued on in this direction, it would have origin symmetry. It doesn't fold on the x-axis. If you fold it along the x-axis, it doesn't match up. It would make something down here. There's no graph down there. Plus, it's a function, and x-axis symmetry cannot happen with a function. It doesn't have y-axis symmetry. We can't fold on the y-axis. And we could almost rotate, but not quite. Now, even, odd, or neither. Now, even functions are y-axis. Odd functions are origins. So since I said it was neither, then this is my answer for the function type. It's neither. It would almost be odd. We got to extend it off this direction or cut it off here. All right. And the last question here are the intercepts. There are 3. -3, 0 is an intercept. 0, 0, which is not listed here, but you can see it on the graph. 0, 0, and 3, 0. Those are the intercepts of the function. That's part G. 0, 0, 3, 0, and -3, 0. Okay, we're going to move on to the next part of 12 and then do 13. So the next part of 12 here asks you to answer these questions for this graph. Domain and range. Domain are the x values. It's going to be -5 on the left-hand point to the right-hand point, which is +5. We'd include those because they're solid points. Y is high and low, so we look for low. Low, 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 low is -3 is the lowest. So that's where we'd start. Highest is this point, which is +3. So that's a range. Intercepts. There are 3 intercepts for part B. -2, 0, 0, 2, and 2, 0. So that's part B, the intercepts. F of 1. We would look at where 1 is on the x-axis. We read up to the graph, and the answer is 3. F of 1 is 3. What values does f of x equal -3? As I did before, I drew a line at -3 and found out where that happened. It's going to happen twice here at these 2 values. So D is x equals -5 or x equals +3. And then letter E asks you to solve when it's less than 0. So when it's less than 0, let's erase this. It's less than 0 is the line here. Less than 0, that's everything below this axis right here. So there's going to be an interval for part E. So there's nothing here. So it's less than 0. It's going to be this piece here. So that's going to happen at -5. So our first interval where that happens would be from -5 to -2. But it's less than, so we don't have we have a parentheses there. And then we start at 2 and go to +5. So all of those, that's our interval where that occurs. We can include the endpoints in the brackets because they're endpoints on the thing, but we can't include these points because it just says less than. So we're looking at this section, what the x values are there and what the x values are here. And these are the x values for that section. So those are the x's, the domain or the intervals for that. All right, now the last thing here is determine whether it's odd, even, or neither. Algebraically, all you have to do is test f of -x. If you get the same function, then it's even. If you get the opposite function, then it's odd. Usually you can tell by looking at the powers, because when you raise it, so 18, we're going to have to continue 13 on the next one because we're running out of time again. So in the next section we'll finish 13 here and go on.